Make sure you have section 6 out in your notes. We're going to be doing 6 and 7 today. 6 and 7 today. And section 6 is on solving logs using the laws of logarithms that we learned yesterday. So let's go ahead and give these a shot. I'm going to give you several examples, and then I'm going to have you guys practice it in the homework. There it goes. The goal for solving. They've already put the power rules back here for you, or the log rules, including the product, quotient, and power rules. As a reminder, they're the exact ones we used yesterday. Here is your goal. Condense the logs to a single statement on each side. So log equals log. If you can do that, then you can drop the logs, just get rid of them, ignore them, and set the insides equal to each other and solve for x. You've already been doing some of this. We did some stuff similar to this in section 3. So let's try it. Question number 1. I see 3 log base 3 of 2 equals log base 3 of 4x. The problem right now is this 3 out in front. So again, phones away, focus up here. Take a look at your notes. Does everybody have notes that needed them? Take that 3, put it up as an exponent using the power rule. This becomes log, actually let's make this a little bigger. Log base 3 of 2 to the 3rd power equals log base 3 of 4x. Once I get it to log base 3 equals log base 3, I can make a new equation with just the insides. So 2 cubed equals 4x. 2 cubed, 2 times 2 times 2 would be 8. 8 equals 4x. Divide both sides by 4 and we get x is 2. There's our answer. We did something like this in section 3. It was real similar. The trick is that there's going to be a little bit more work to get the logs together because you didn't know the rules of logs before. Number 2. I see 2 out in front. Bring it up. Log base 4 of x squared equals log base 4 of 81. X squared equals 81. We can ignore the log base 4 because it's the same on both sides. So it's just x squared equals 81. How do I solve this? Square root on both sides. Square root, square root. Now, everybody, here's something important. Normally, I take the square root of a square and I get plus or minus 9. But what numbers are we allowed to put into logs? Can I put a -9 in here? No. So the -9 doesn't work. It's actually just x equals +9. You need to check these. You need to check these. There's going to be some where none of your answers work because you're trying to put negatives into the log. Or rather, you're trying to put a number in that will make the log evaluate a negative, which doesn't work. Number 3, log base 2 of x. Oh, but I've got 2 logs on this side. Combine them. Bring the 2 up as an exponent. Log base 2 of x equals log base 2 of 4 squared times 3. Now, again, those of you that were gone yesterday, so like, Aaron, is this making sense as far as putting the 2 logs together? All right. So now that I have 2 logs, 1 on each side, nothing outside the logs, I can just set the insides equal. X equals 4 squared times 3. 4 squared would be 16. X equals 16 times 3. 16 times 3, x is equal to 48. You could always plug it back in and check, but really the main thing you want to make sure, the main thing you want to check is when I put that number in, does it make my log or the inside of my log negative? If it makes the inside of my log negative, it's not going to work. Number 4, log base 5 of x minus 2. Here, log base 5 of 10 divided by 2, right? The minus sign means division. You've got those rules right there at the top of your notes. 10 divided by 2. So I end up with x minus 2 equals 10 over 2. Or really, you can simplify that right now. 10 divided by 2. 10 divided by 2 would be 5, right? Yes. Yes, if the log has a negative, you're dividing the insides. So this is the quotient rule right up here. We're just going backwards. If I have 2 logs, one minus the other one, I can condense that into a single log with division inside. So let's finish this one. This would become 5. Let's go ahead and I'm going to go ahead and simplify that right now, right? 10 over 2 would be 5. I can just add 2 to both sides. Log base 5. Oops, sorry, no logs. We got rid of those. X is equal to 7. So again, once you get log equals log, you set the insides equal, you're solving like you did back in freshman year. Right? Just basic 2-step equations or 1-step equations. Next one, number 5. Okay, so far they've all been pretty easy. This one is a little harder, and this is one where we very well could end up with an answer that doesn't work. Let's try it. I'm going to combine these logs. Log of x over x minus 4 equals log of 5. Is everybody clear why it's a division there? Right? Subtraction becomes division. So I get x over x minus 4 equals 5. How would I solve this? How do I solve a fraction equals a number? So you got a couple of options. You can make it 5 over 1. You could multiply both sides by the bottom. If you make it 5 over 1, you can cross multiply and get x is equal to 5 times x minus 4. And then do the distributive property. 5 times x is 5x. 5 times negative 4 is negative 20. So 5x equals, or 5x minus 20 equals x. I could subtract x from both sides. I'm gonna have to go up here, give myself a little bit more room. 4x minus 20. Okay, a lot of people get stuck when they do something like this. So I said I subtracted x from both sides. So I could do that, minus x. What's missing though? I can't solve this right now. I've made a mistake, kind of. I need an equal sign. What's it equal to right now? 0. That's important. You need that equals 0 to finish solving. Right? Because I subtracted the x from both sides. Say that again. You could do that too. Both ways work. Aaron's asking, could we subtract 5x from both sides? Then you get negative 20 equals negative 4x instead of positive 4x equals positive 20 that I'm about to do. It will work both ways, Aaron. I do it this way so that I don't end up with those negatives. Adding 20 to both sides. 4x equals 20. Divide both sides by 4. X is equal to 5. So let's check though. I think this is okay because I get log of 5 minus log of 5 minus 4. So it'd be log of 5 minus log of 1 equals log of 5. So that one actually does work. I don't end up with any negatives inside logs. You just have to double check. All right, number 6. Number 6, log of x to the 2/3 equals log of 27 minus log of 3. Log of x to the 2/3. And Ashant, again, you just came in. We're trying to get it to be 1 log on one side equals a log on the other side, because then we can just set the insides equal. So this becomes log of 27 divided by 3, which is everybody good with that 27 divided by 3 being 9? Right, 27 over 3 would be 9. So I can set the insides equal, x to the 2/3 equals 9. You solve problems like this in unit 6. Okay, it's the same thing. Anybody remember how we get rid of that fraction exponent?
You do the reciprocal.
You raise it to the reciprocal. So we're going to raise both sides to the 3/2 power. So to the 3/2 power, to the 3/2 power. These all cancel out. I get x is equal to 9 to the 3/2. Technically correct, but we really want to know what that is. There's a nice answer here. Remember that the bottom number is the radical or the root. What's the square root of 9? 3. So this is really 3 cubed. That's good. What's 3 cubed? That's our answer. X is 27. So are we good up until here, the 9 to the 3/2 power? So then here, we're saying that the 2 on the bottom, that means a square root. And the square root of 9 is 3. But we still have the 3 on the top to deal with, so 3 cubed is 27. Technically, you could do 9 to the 3rd power, get a giant number, and then take the square root of that, and you would still get the same answer. But typically, it's better take the square root, then raise it to a power. Yes. So then 9 was from up here, the 27 divided by 3. All right, at this point, yeah. So are you good with the 2 down here, meaning square root, right? The 2 on the bottom of a fraction is the radical. So this is the square root of 9. So the idea is right here, if you want to write this a different way, this, I can say this 2 on the bottom is a square root of 9. But then that answer is cubed. Because the fraction exponent, the bottom number is the radical. Square root, 3rd root, 4th root. So this one's a square root of 9, which gets us 3. And then 3 cubed is 27. All right, I want you guys to try some of the homework problems now. Let's look at, where's the worksheet? Okay. If your worksheet again has a bunch of extra space, I'll have to make some space for this so I can actually solve some of these. You should be set to do everything. We're going to do evens again. We're going to do evens again all the way through 32. For starting right now, you should be able to solve all the way through number 10. So let's take some time here. Do numbers 2, 4, maybe 6 if you have time. 2, 4, and 6. Start there. 2, 4, and 6. So you're going to do 2 through 32. 2 through 32 even. LN? Remember the natural log? Is that the one you're looking at? It's the exact same as any of the other logs. Remember, you're just going to get rid of them. So it's log base E, but it doesn't actually change how you solve these. So 9.6. 9.6, numbers 8 and 10 on the homework. Let's talk through number 8. So for number 8, I need to combine these two logs. How do I do that? Sapphire, how do I put together these two logs? Division. So everybody, we've got 3x plus 5 divided by x minus 5 equals the natural log of 8. Once you get it to be a natural log on both sides, what do we do next? Rania, what's our next step here? Once I have a natural log equals a natural log.
You can take the logs away.
Yep. So just 3x plus 5. Let me use a different color here to keep track of the different steps. 3x plus 5 divided by x minus 5 equals 8. How am I going to solve this now, though? It's very much like one of the ones we did in the homework or in the notes about how would I solve this, or what would be my next step? Yeah, so we could do 1 times 3x plus 5. So that would get me 3x plus 5 times 1, or just 3x plus 5, equals 8 times x minus 5. Now it's like 2 3-step problem. Brian, what would be my next step for solving this? X or 8? Yes, okay. So 8 times x, 8 times -5. Now there's a couple ways you could do this in a couple of different orders. Alani, what would you do next to solve this one? Which ones? So yes, I want to put the 3x together with the 8x. How do I do that though? Because they're on different sides of the equal. Yeah. So let's subtract the 3x. That gets me 5 equals 5x minus 40. Kiara, what would I do next to solve that one? Okay, you could divide by 5 and it would actually work out okay here. If you, as long as you divide everything by 5, it'd be 1 equals x minus 8. I would add the 40 to both sides first and then divide, just to be safe. So if we add 40 to both sides, we get 45 equals 5x. Divide both sides by 5. X is 9. Does that make sense? And so we can go back up here and check. Just make sure we don't get any negatives inside the log. 3x times 9 plus 5, that's fine. 9 minus 5 would be 4. That looks fine. So I think we're okay. There's no negatives inside the logs, nothing that would be illegal, nothing that wouldn't work. And then number 10. Number 10, I've got x to the 4/3 equals log of 32 minus log of 2. How am I going to put these two logs together? Abby, what do I do to combine those two?
You do log x to the 4/3 equals log 32 over 2.
Perfect. Log of 32 over 2. Divide those two. 32 over 2 gets us 16. So log of 16, log of x to the 4/3. Taj, what do I do next? Yeah, I'm not going to use the word cancel. You guys are fine if you use that, but know that we're not crossing them off. We're just saying I only need the stuff inside. So x to the 4/3. That didn't work. Equals 16. How do I get x by itself then? Sarah, what would you do next? Say it again. Yes, so raise both sides to the reciprocal, 3 over 4. Choose a different color here. 3 3 over 4, 3 over 4, 3's cancel, 4's cancel. X is equal to 16 to the 3/4. Now, I told you guys that you could do this as the 4th root of 16. Yeah. Okay, so I want to show you another way to do it as well. So instead of doing the 4th root of 16, you could also write 16 as something to a power. How can I write 16 as maybe 2 to a power? How many 2's does it take to make 16? 4. So I could write this as 2 to the 4th power to the 3/4 power, so that I would just have to multiply those exponents. I could do 4 times 3, get 12, divide by 4, and just get 3. This ends up being 2 to the 3rd power, or 8 would be my final answer. If you did the 4th root of 16, it would work just as well. 4th root of 16 would be 2, and then 2 cubed would be 8. It just depends on how comfortable you are with 4th roots.
Oh, did you?
So I took that 16 and said, okay, 16 is 2 times 2 times 2 times 2. 16 is 2 to the 4th power. And that will often make it easier to simplify this.
Why is there a Y equation?
3/4. Some of my 4s, it tries to simplify my drawing and make it a diagonal line instead of an angled line. So yes, if you're ever not sure what something is, raise your hand and ask. Okay, yes. If you left it as 16 to the 3/4, I might give you credit, or at the worst, I'd take off 1 point. But I really like the 8 is going to make a lot more sense to us as far as what that means than 16 to the 3/4. All right, everybody back to the notes, and let's do a couple more on the back side of the notes where there's just a single log or only logs on one side. If we only have logs on one side, we can't make it log equals log. So we're going to have a different way of solving these. These typically you end up rewriting them as an exponent or as exponential equations, unless you can just evaluate the log. If you see log base 2 of 32 and you know that that's 5, you can just stop right there and change it to 5. But most of these are going to be like number 7. Combine the 2 logs. Guys, we did this in section 3. It's just the extra step of combining the logs. Log base 8 of 4x equals 2. This is where we're going to use the rule that I gave you yesterday of switching back and forth between log form and exponential form. Focus. The 8 comes down, the 2 comes over and becomes my exponent. It's equal to whatever was inside the log, 4x. 8 squared equals 4x. Does everybody understand how to do that switch from log to exponent form? The base of your log becomes the base of your exponent. Whatever you're equal to is your exponent, and whatever was inside the log is what you're equal to. Are we okay there? So 8 squared equals 4x. 8 squared is 64. We can divide both sides by 4 and get x is equal to 16. Are we okay? Number 8. Same thing. Log base 3 of 54 over x equals 2. 3 comes down. 3 to the 2nd power equals 54 over x. Again, whatever was inside, log comes down, the other 2 switch. 3 equals 54 over x, 3 squared equals 54 over x. 3 squared would be 9. And here you can either make this 9 over 1 and cross multiply, or just multiply both sides by x. Either way, you'll end up with 9x equals 54. Divide by 9. X is equal to 6. We still following along? Different set of steps, kind of, because you only have logs on one side. But once you make that equation, just basic solving. Number 9, 2 comes up, becomes log base 6 of 2 squared plus log base 6 of x equals 2. Put these two together. Log base 6. Are we okay with 2 squared being 4? X equals 2. 6 comes down, 2 comes over. 6 squared equals 4x. Six squared is 36. Divide by both sides by 4. X is 9. Right now, I'm just giving you lots of examples so you can see all the different ways, permutations that you could do these. But the general format is combine the logs, switch to exponent form, and solve. Okay, this one. Whoa, log base pi. Why not? It's a number. You can do it. Steps are the same. Log base pi of 5x equals 9. Pi comes down, it's your base. Pi to the 9th power equals 5x. Divide both sides by 5. That's your answer. X is pi to the 9th power over 5. It's a strange answer, but it works. You could evaluate this with a calculator if you wanted to. Yes. Number 11. Okay, here we get into something new. Log base 4 of x times x minus 6 equals 2. When I switch this, 4 comes down, 4 to the 2nd power equals x times, come on, x times x minus 6. 4 squared equals x times x minus 6. I can distribute the x in. I get x squared minus 6x equals 16. If you have x squareds and x's, you have to get everything on one side and factor. So we've been doing this all year long. Here it is again. Subtract 16. X squared. Actually, let's do 0 equals. Put it on the side. 0 equals x squared minus 6x minus 16. I need two numbers that multiply to negative 16, but add to negative 6. It's not 4 and 4. What's another way to multiply to make 16? 8 and 2. That subtracts to 6. So this is going to be x minus 8 times x plus 2. So I get two answers here. X is 8 and negative 2. Is everybody okay with finding those without me actually setting up the two equations and solving? You could do it. X minus 8 equals 0. X plus 2 equals 0. Solve them. Get the opposites. One of these doesn't work. The negative 2 does not work because if I plug it back in here, I get log base 4 of negative 2 plus log base 4 of negative 8. Neither of those evaluate. I cannot get answers for those. The negative 2 is no good. That is going to be on the test. There's going to be one exactly like that on the test. Okay. You need to be able to factor, solve, and eliminate the one that doesn't work. Number 12, literally just the natural log. Same idea, natural log of x over 4 equals 8. What's the base of a natural log? Base e That's correct. So this would be log base E of x over 4 equals 8. E to the 8th power equals x over 4. X over 4. Multiply both sides by 4. Our answer is x equals 4 e to the 8th power. That's what I want. Number 13. I'm not going to finish number 13. I'm just going to start it for you. Log base 2 of 8x divided by x minus 1 equals 4. So it's 2 to the 4th power equals 8x over x minus 1. Do the 2 to the 4th power, make it over 1, cross multiply. We've done ones like that, so I'm not going to finish it unless you need to see that one. If you do, let me know, and I'll do it for you later. Number 14 is another new thing, just slightly. This one, multiply these together, log 4 times 250. 4 times 250 is 1,000. But wait, it's already equal to x. Yeah, the base is 10. Guys, what's log base 10 of 1,000? 3. So you can just evaluate it. This one, don't switch it to exponential form if you've already solved for x. Just simplify. So we get a couple like that. Get a couple like this. 9 to the 0 power equals 2x minus 13. What's 9 to the 0 power? 1, not 0, 1. So we get 1 equals 2x minus 13. Add 13 to both sides. 14 equals 2x. Divide by 2. X is 7. Again, I'm going kind of fast now because you've seen most of these. I just want you to see, okay, what if it's this way? What if the x is over here? It's all the same kinds of steps though. Number 16, I'd combine these. Log base x of 8 times 2 times 2 equals 2/3. X, thank you very much. X to the 2/3 equals 8 times 2 is 16. And then it's what we did before, right? Raise it to the reciprocal power, raise both sides to the 3/2, and simplify. So the square root of 16, thank you, would be 4 cubed, be 64. All right, we made it. So you've seen all the examples now. We're gonna go back to the homework. I want you to work on maybe the back page, a couple there. So like 12, 14, 16. I'm gonna give you 5 or 10 minutes, depending on how well we're working, how much we get done. So on the homework, were there any problems 12 through 16, 18, 20 that you guys were stuck on? 14? Okay, let's do 14 together. So number 14, take the 2, make it your exponent, log base 6 of 2 squared plus log base 6 of 18x equals 3. Is everybody good with the 2 squared right here? 2 squared is 4. So this is really 4 times 18x inside our log base 6 equal to 3. And then I'm going to bring the 6 down. I'm going to bring the 3 over to be my exponent. And then the 4 times 18x. Is everybody good with 4 times 18x being 72? Is that right? 18 times 4, 72x. And then 6 times, or 6 to the 3rd power. No, it's someone backing up. So,
That's not the part.
no. So 6 times 6 times 6. What's 6 times 6 times 6? 216, 2 something.
216.
Okay, it is 216 equals 72x. And then just divide both sides by 72. Go ahead and try it on a calculator. Should work out really nicely. Is it like 3? What's 216 divided by 72? It is 3. Excellent. So we end up with 3 is x.
And then maybe 2.
Now, everybody's full attention right now. Were we good with that one? So you're doing 16, 18, 20. You reach the end of the page. You are not done. I said 2 through 32. Keeps going. 22, 24, 26, 28. Now, the nice thing is that 30 and 32 are multiple choice. Let's talk about 32 right now, though. Let's do 32 altogether. Yes, Ashan. Everybody, look at 32. Then look at Ariadna and Bella, Shoa and Domingo. Do you see any mistakes that they are doing? Somebody, most of these, made mistakes as they were going through. Notice they all rewrote the problem. So somebody just call it out. Do you see a mistake? What's the mistake? So what did Shua do? Looks like they grouped the log base 3 and log of x, or sorry, log of 3 and log of x together, even though this one doesn't have a 2. Does that make sense? They can't do this because now you're doing 2 times log of x. It's double what it should be. This one's no good because of step 2 right there. Any other mistakes? Does Domingo make the same mistake? No. Sorry, I didn't give you enough time. Domingo also made the same mistake. How about Ariadna and Bella? Step 3 for who? Oh, right here, right? Log of 9 plus log of x should be log of 9 times x, not 9 plus x. Is everybody good with that? So again, their mistakes right there. Which student solved correctly? Ariadna. Are we okay there? So I just did one of your problems. You hopefully only have like 6 or 8 left on those. At this point, though, we're going to switch over to section 7. And switch over to section 7.